Wonderful. So it's great to be back and to talk with you about some ideas about longevity and the future. I'm Vince. I'm assuming you can hear me. Okay.
I can hear you, Steve.
Great. So let me tell you a little bit about Vince Giuliano and the Anti-Aging Firewalls blog. Vince is 92 years old. He's probably the oldest living longevity science blogger in the world. And he's been doing his blog 12 years, 125,000 registered subscribers, 650 articles, and they're all kind of journal grade, reviews of the literature. And he's also my best friend. And I am a software engineer and a cognition and biohacker. And I blog under the alias High Desert Wizard at longevity.org. And I'm also the organizer of a good number of meetups in Bend, Oregon. Feel free to contact me via those. So what we're going to talk about today, our outline has changed. Unfortunately, I was making last minute changes to the PowerPoint, and I couldn't get the OneDrive presentation up to the cloud to share it with Dr. Coehlo. So we're going to use the version that we had just before as of 3 o'clock. So we're going to review briefly the inflammatory reflex and the cholinergic anti-inflammatory pathway. I'm going to talk about Junging a bit, this idea of Junging. Then we'll talk about the science of epigenetic turns. I understand from Dr. Coehlo that you're familiar with epigenetics. And then we're going to talk about something more complex, histone demethylase rejuvenation, some interventions, and we have some ideas about the Copernican delay and personal health. In the last talk, we talked about, you'll recall, we talked about the inflammatory reflex and the cholinergic anti-inflammatory pathway. Today, we're going to talk about not a whole organism level set of biological objects, but we're going to talk about cellular biological objects. And we're really going to focus on interventions on April 9th in a talk at the London Futurist Meetup, 8 a.m. on Saturday, April 9th. And there are some exciting things going on to trigger these mechanisms that are the subject of these two talks. Now, you may recall that we talked about the inflammatory reflex and the cholinergic anti-inflammatory pathway. And here are some ways to trigger the cholinergic anti-inflammatory pathway. You can trigger it with galantamine, some acupuncture approaches, systematic breathing techniques, some meditation approaches, neural sound stimulation, electromagnetic pulses generated by PMF. For example, I've just learned in the last month that this device called, let's see if I can get it out of the head. If I hold it just right, put it around my neck or do it here, turn it on, looks like a baseball cap kind of. I can trigger what amounts to the cholinergic anti-inflammatory pathway by what are called low-frequency pulsed electromagnetic waves. And what it actually does is it triggers REM sleep, which is related to triggering that anti-inflammatory pathway. So I try not to wear it in public too much so I don't look too weird, but it's kind of fun. And you can also trigger it by red and near infrared light devices, a lot of dietary substances, including herbs. And we believe This hasn't been shown definitively in a study, but we believe it will be. The cholinergic anti-inflammatory pathway can also be triggered by multiple natural processes. We believe it's triggered by REM sleep, and we think that the reason sleep is so important, and especially REM sleep, is because if you're not getting a lot of REM sleep, then you're not triggering the cholinergic anti-inflammatory pathway. But in mammals is the most significant innate anti-inflammatory mechanism. And also, the PowerPoint is on, Dr. Coehlo has sent you a link, and you can find out more about how to trigger it here. But today we're going to talk about younging, and I'm going to do a brief introduction before Vince gets going. Younging is really about the impulse of evolution and what evolution has established in us for healthy longevity. Now, in the longevity science movement, if you follow, developments, there are a lot of technology innovations going on. CRISPR, stem cell generation, and all those are great, using external technology in more interventionary ways that actually get into your body. But there are ways to trigger basically two mechanisms in our bodies, in mammals, to trigger healthy longevity. And the first we talked about last time, which is this brain to spleen mechanism, which reduces inflammation in the blood circulation, the inflammatory reflex. And the second one is what we'll talk about today. It's the demethylation of histones. And Vince is going to talk about that. It's a more complex topic, and it's a more recent topic. It was impossible to actually understand that the mechanism could be triggered until around 2015, 2017, 4 or 5 years ago. So let's take a look. Let's do a quick review of what we talked about last time. We have this brain to spleen mechanism to impact the blood circulation, the cholinergic anti-inflammatory pathway. In mammals, including in humans, evolution has established a brain to spleen mechanism that reduces inflammation and non-trivially promotes survival probability throughout the organism. The function of the mechanism is to reduce inflammation throughout the organism and hence maintain its health and longevity. Ancient humans around the world discovered substances and developed health techniques and practices that leveraged the existence of the mechanism, even though they didn't know how it worked. For example, we talked last time about how the hookah, acupoint, can trigger the cholinergic anti-inflammatory pathway and even increase survival probability when lethal endotoxin is administered. That's a remarkable thing. But we only found out that was true in 2013, 2014. But the hookah acupoint has been a feature in traditional Chinese medicine for thousands of years. So ancient peoples, especially ancient Asians, South Asia and East Asia, were triggering these techniques and trying to come up with explanations, even if they weren't the science-based explanations we know today. And we talked about last time about how the cholinergic anti-inflammatory pathway is composed of several kinds of elements, cell types, organs, receptors, nerves, blood circulation, triggering substances. A thing we didn't emphasize last time is that the cholinergic anti-inflammatory pathway transforms especially powerful inflammatory cytokines that are potent in their ability to reduce threats to our host, the host organisms that we are, but also do profound damage to healthy cells, right? These are called macrophages. Macrophages mean something like the eaters of, it's from the Greek, they eat substances. And there are two phenotypes. The M1 phenotype is the potent, heavily armed soldier that fights the enemies, but also the metaphor is can also do harm to the host. The M2 phenotype is, the metaphor is like a UN peacekeeper doing healing operations and reestablishing homeostasis. And the CAP has been shown to transform M1 macrophages into M2 macrophages, which is a terrific thing. That's a key way that it increases survival probability. Now today, just to give you a high-level overview, whereas the last mechanism, involved organs and lots of cell types, the brain, the spleen, the blood circulation, the nervous system. This first, I should say also, this mechanism, the cholinergic anti-inflammatory pathway, maybe began to develop in mammals about 150 million years ago. We know it existed 100 million years ago in some form because it exists in rodents today. Meanwhile, a more ancient mechanism is a cell and intracell related mechanism. And you can see that there are, just to show you a picture of components of a cell like mitochondria, like DNA in the nucleus, there's the cell, there's the nucleus. Mitochondria also has DNA. A plant ancestor, a plant species ancestor from 600 million years ago also leverages some key mechanism components of this mechanism that also is in humans. And specifically, that's this histone called H3K27. And our bodies are composed of about 35 trillion cells. That's a lot of cells, of course. The biological function of the mechanism is to manage the fighting of variables that threaten organism health and maintain homeostasis. Ancient humans, 3,500 years ago around the world, discovered substances and developed health techniques and practices that leverage the existence of this mechanism, again, like for the CAP, without having a modern scientific understanding of how it works. There are a lot of traditional Chinese medicine and Ayurvedic medicine, herbal substances that actually trigger this pathway. I'm very familiar with coronary artery disease because I have it. And it turns out that in the West today, Western established medicine, there are two very expensive cholesterol-related drugs that are only prescribed when statins don't work. And it's hard to get a prescription for these. They're very expensive, and they have a certain function they remove. They inhibit LDL cholesterol from even being expressed. And it turns out that in traditional Chinese medicine, the most significant traditional herb prescribed by ancient practitioners in China was a certain herb that in English is called danshen. Can't remember the Chinese name. It's called danshen. And in fact, its biological target of this ancient herb discovered thousands of years ago is exactly the same target as these very expensive drugs developed in modern establishment science. All cell elements are related to the mechanism, including especially the mitochondria. and including this thing called the electron transport chain. And I'm just showing you an image of the 4 complexes of the electron transport chain. The fascinating thing is that a key biological substance called JMJD3, that's the acronym, the name of it is Jumanji something something. It also directs macrophages to become M2 macrophage phenotypes. Now, the science of macrophage phenotype is relatively clear, and it's clear that the M2 macrophage phenotype is a positive phenotype when it comes to healing. The remarkable thing, stop to think about this, the cellular mechanism that evolution established in mammals and in all animals actually for healing and reducing the risk of autoimmune conditions, that substance transforms macrophages into the M2 phenotype. And so does this mechanism we talked about before, the brain to spleen mechanism, cholinergic anti-inflammatory pathway. It also transforms macrophages into M2 phenotypes. What I take from that is the M2 phenotype is something to focus on and learn about for personal health, right? But if Mother Nature cared so much to cause these 2 mechanisms to trigger M2 phenotypes, it must be important. And so this is as I was saying, this is a relatively new batch of science in 2000, not batch of science. This is a relatively new literature in the longevity science literature. And in 2015, a team led by Richard Morimoto at Northwestern University discovered that in the worm C. elegans, a small worm often used in longevity science studies, that stress responses, which are healthy, are rapidly repressed at the onset of egg laying in C. elegans. The transcriptional repression of stress responses is due to increased H3K 27B3, and it reduces JMJD3 for stress response genes, and the repression is thought to be regulated by germline stem cells, and the repression of stress responses reduces long-term survival probability. So essentially what happens at the beginning of young adulthood in this worm C. elegans, we go to the graphic now. This is a young adult, JMJD3, which is a rejuvenating, regenerating mechanism in all animals. Segue, it is a required part of the mechanism that rejuvenates and regenerates limbs that are destroyed in reptiles. It's required for regeneration of limbs in reptiles, and Vince will talk a little bit about that. In young adulthood, it's expressed at a high level, and it generates something called heat shock protein. Heat shock proteins are healthy. You've heard of, sauna is healthy. A reason why is because it triggers heat shock protein. But at the time of procreation, JMJD3 is reduced, and that increases this histone, it methylates this histone called K27B3, and heat shock protein is reduced. You'll notice that all these round objects here are lighter than up here, and that means they're reduced, and Vince will be talking a lot about that. So what that amounts to in young adulthood, that means that in those worm C. elegans, that the resilience that aging reduces, the young are always more resilient than the old. There's a switch in this worm, C. elegans, that initiates this decline of organism resilience. Now, when we saw this study about resilience and the switch that turns it off, turns it down, in 2015, we thought, well, just because it exists in the worm doesn't mean it exists in humans, right? But then in 2017, Seth Grant, University of Edinburgh in the UK, published a study with his grad students, the Genomic Lifespan Program. And what this study does is to confirm that, in fact, there is also this diminishing of resilience in humans and Homo sapiens in young adulthood about the age of 25. And we're just displaying a couple of graphic figures from the study. The reason we know this study is important is because biological age can be estimated with accuracy by the genes selected for the study. Let's take a look at what that means. Here are two graphs, one for humans on the left, one for mice on the right. And here is the predicted age by looking at what they did is they took a set of genes and used machine learning technology to compute a predicted age of both the humans and the mice. And the correlation between the predicted age in both the humans and the mice highly correlated with the actual age in years for the humans and actual age in days for the mice. And that's why you see these dots arising from close to the XY 0 point, close to 45-degree angle. That tells us that high correlation of predicted age with biological age of the genes they selected in the study tells us that they're looking at important genes, right? Does that make sense? Then what they did is to do an analysis of gene expression of these same genes that they used to predict biological age. And what they found is that in mice, about 4 or 5 months in, there was a dramatic turn of expression of these genes from spiking from the time of birth to about 5 months, and then a dramatic reduction of expression of those genes. And in humans, it's even more remarkable that in humans around the age 25 for males, around the age 26 for females, there was also a dramatic directional turn in the momentum of the genes being expressed. You can see from the age of the time of birth up to about 25 years old, there is increasing expression of the set of genes. And then at a certain point, there's a dramatic decline all the way up until the age of 40. And this amounts to, what it amounts to, we think, this study is 2017, it will take another 10, 20 years to really know the larger meaning of it. But what we think it means is that at around 25, 26 in females, 27 in females, there is a turnaround in the momentum of expression of genes that are required for organism wound repair and rejuvenation, resilience, if you will, right? And often this mechanism is called the stress response. You've heard of healthy stress response. It's also called hormesis. And so probably many of you are getting to this age. I have a daughter who's approaching this age, and I talked to her about this a few times because there are certain things you can do, practically speaking, to keep your stress response genes higher. And we'll mention those in a list today, and then we'll talk about them in more detail at the London Futures meetup on the 9th. An amazing thing. In these two studies, the Morimoto study in 2015 and the study by Seth Grant in 2017. What does it mean? Here's what we think. We believe the Seth Grant study, the epigenetic turn in humans, is what's called the ortholog of the Morimoto study turn in the worm C. elegans. An ortholog are gene sequences derived from the same ancestral gene present in two species' last common ancestor. So what that means is, at some point in the long past, hundreds of millions of years ago, we had a common ancestor with this C. elegans worm. And we think the Morimoto switch in C. elegans amounts to a turn of a gene that's an ortholog of what Seth Grant, the Seth Grant study found in humans. Both studies, and why do we think so? Both studies implicate stress response genes, and they involve inactivation of multiple genes through histone, H3K27, MEF2 and 3, methylation due to the inactivation of this substance JMJD3. There is a difference, though, if you really stop to think about it, between the Morimoto study related to C. elegans and the Seth Grant study related to humans. And it has to do with the timing of the epigenetic turn event, right? In the C. elegans study, in the Morimoto's 2015 study, the turn occurs at the time of first procreation in the worm. The worm procreates, and that's when the epigenetic turn occurs. In humans, it doesn't occur until the mid-20s on average. In other words, it occurs well past the time of first procreation capability. Now, we're in a time of speculation about what all this means. And this part on the right, this is merely speculation by Vincent and I about the meaning. We speculate the variance in the timing of the turn of expression is related to the level of systemic inflammation in the organism. We know that inflammation increases significantly in humans in their 20s because of, among other things, the findings of the Seth Grant study. We haven't found a study yet that shows that procreation in C. elegans is demonstrably related to inflammation expression. But I went looking today for the first time for the study, and I sent you an email, Vince, with the link. We think this is what is happening. The turn isn't related to procreation per se, but to some inflammatory context. That's our speculation. And then we come to a final study that is really telling for the details that Vince is going to talk about. We're loading up, this front part of the study with these long survival probability curves to try to convince you that it's really good to try to pay attention and learn about this because it is complex. When you trigger the mitochondria trigger the mitochondria, and especially the electron transport chain in known ways, as you can see in the right, you can significantly increase survival probability in the face of lethal stress and inflammation. This graphic on the left is the graphical abstract for this Morimoto study of 2017. And what it shows is that if you trigger healthy mitochondrial stress, then heat shock protein 70 increased, mitochondrial heat shock protein 70, it increased, oxygen consumption decreased. How could that be important? What it means is that the organism can function in a healthy way with less oxygen, and that's a good thing. And then the final variable they found is that fecundity or reproductive potency declined a bit while heat shock protein increased, and you get five positive developments as a result of triggering mitochondrial stress, stress-resistant systolic proteostasis. In other words, proteins are processed in a more healthy way, increased health spans, and stress resistance, mitochondria homeostasis. So triggering this cell level mechanism through mitochondria stress is a great thing to do, especially if you're in your mid-20s. I'm trying to trigger it anyway, even though I'm significantly older. And we put this in to show you, this is the Morimoto 2015 graphic, that when you trigger, this is from another study, this diagram on the right, when you trigger electron transport chain perturbation in the mitochondria, what you end up doing is increasing JMJ83, and that increases mitochondrial proteostasis and longevity. And at the end of the talk, we'll talk about ways to trigger mitochondrial electron transport chain perturbation. We threw this in. Vince is going to talk a little, mention this in passing at the end. There are ways now that, I guess for 10 years now, scientists have been able to predict biological age as distinct from chronological age by using machine learning techniques against epigenetic data. And here's a list of the aging clocks that have been developed. You can actually get order a blood test online. You get a blood sample, send it back, and they will calculate your quote biological age. And one really interesting fact is that the leading scientists around this science says, once we know how to accurately measure aging, that is biological aging, we will be able to study it and to defeat it. One biological clock is especially interesting. It's called the Grimm aging clock because it predicts an individual's lifespan and health span. It doesn't answer the question, how old are you? But instead it answers the question, how much time do you have left? Which is, that's why it's called Grimm age, because it provides grim results. So that is my portion of the talk for now, and Vince will take over from here.
Thank you. Let me take over. One of the important takeaways from what Steve has been discussing is that around the age 25, there is a massive change in gene expression. That is, a number of genes are downregulated and shifted, those spiky things. And this corresponds to something which happens in more primitive organisms. So you saw it also for nematodes. And we think it applies across the spectrum to most living organisms, at least those of a certain level of complexity, like insects. And the question is, what is happening? We believe there is evidence that there is a common factor that comes into play about age 26 that affects this shift. And it affects a shift from the early stages of life where you're in growth and development to the stages of maturity until you get older. And that shift has to do with something called JDJM3. I'm going to talk about what that is. And so much of what we're going to be doing here is talking about what the hell is this JDJM3? How does it come in? What is it common to? It underlies younging, a form of reverse aging. It turns out it relates to and explains most, possibly all, as far as we know, of youth-producing interventions, things we can do like calorie restriction. It applies across all spectrum, all species, and it's supported by thousands of research publications. In other words, have we found a really key? Steve and I believe we've done this because the identification of this substance as being key was something that Steve and I really did based on all these studies like Muramoto and Seth Grant that he's discussed. And we believe it's very fundamental. Next slide, Steve. Again, we believe that this data has been in the research community in plain sight. It's supported by thousands of researchers. It's actionable today. That is, there are things we can do. This is not a case of there's a drug that you now costs $60,000 a dose and it may be effective. But no, these are practically actionable things that normal people can do today. And we believe that when you integrate across all of these things, we are very close on the road to having a grand unified theory, a GUT for aging, rather than as a bunch of disparate, different competing theories that don't necessarily fit together. Next slide, please. Okay. Now, in nature, this is in nature as nature developed. There are a number of restorative processes that go in within the body that are part of life itself that we would never get beyond the age of less than 1 year old if we didn't have them going. Some of these are listed on the right. Neurogenesis, the birth of new neurons. Natural DNA repair. The DNA is breaking all the time. There's extensive mechanisms that do that. We know some of these because we can see them happen. Wound healing. What happens when you get a bad infection or a big scar like used to be on the back of this hand? You can't see anything anymore. Well, the body goes through a number of processes of wound healing. Control of chronic inflammation. This is a list of some of these. These all have to do with this one thing. There's literature relating all of these things. And the key to them is histone demethylation via expression of this factor JDJM3. And if this sounds like gibbledy-gook to you, I don't blame you. We'll try and explain it, but we're trying to lay out something very complex. We're trying to give you an introduction to quantum theory and relativity theory in half an hour. It's got to be very brief, but we hope this can open the door to you studying these things. We have plenty of literature references. We've written plenty of detailed articles. And there's much you could follow through. You've heard that some species like tadpoles can, you cut off a limb or a tail, they'll regrow it. Certain frogs can regrow legs if you chop them off. Cells themselves can move backwards in their developmental history. All of these factors have to do with this JDJM3. Next slide, please. Now, I'm going to talk about something called methylation, which chemically is the attachment of methyl groups to DNA, but there are two kinds of methylation. Every gene has what is called a promoter site, and we humans have about 30,000 genes arranged in 23 chromosomes, and promoter site methylation can affect one gene or two genes or three genes. It turns them off. They are no longer expressed. They don't do what they're supposed to do. Let's go on to histone methylation. Next slide, Steve. Histones are different. Our DNA is arranged, the DNA along any given chromosome is arranged in something called nucleosomes, which are like spools. And there are thousands of nucleosomes on every one of those chromosomes. And the DNA is wrapped around them. And each nucleosome has a set of histones. The same histones show over and over again. So that when you affect the methylation of a histone, this is like a master switch. It's like those gigantic switches you used to see in the Frankenstein movies, where you pull down a big lever, which can turn off or on thousands of genes. So H3K27ME23 stands for histone 3, position K27, methylation of double or triple methylation. It's the most powerful kind of methylation around. And nature has given us one substance that can turn that off, can reverse it. And that's called JMJD3. It has a companion called UTX. So when you activate JMJD3, you turn off the silencing of thousands of genes. We think that's what happens at 25. We think at 25 years of age or so, there is a radical decline in the expression of JMJD3, which means that the methylation turns on and life goes into normal history over the mature stage rather than the development stage. Next slide. Next slide. Again, histones are structural elements, or like spools. There are the same histone position occurs in every spoon. And normally, the H3K27 methylation is maintained by something called the polycomb repressive complex. You can think of this as being something like the KBJ. It leads to silence chromatism. Genes are not expressed. We have the same genes in every cell of our body. The difference between a heart cell and a brain cell has to do with its silencing status or its activation status. So likewise, the basic message is we can throw these basic master switches which turn off the silence chromatism, turn off the methylation, and activate the genes leading to activated chromatism, and that this single factor, JMJD3, is common to them. Let's go ahead. Next slide. Now, related to histone methylation, which I've just talked about, are the actions of a number of interventions and therapies that we know are health producing and life sustaining. For example, there's a great deal of literature and promotion now of NAD plus and sirtuins. This has to do with the histones being demethylated for the activation of those genes. There's a marvelous substance which has to do with longevity called clotho, sometimes called the magic spinner. And again, you need the demethylation. Hypoxia and oxygen therapy is a marvelous set of stuff that Steve knows a lot about. We'll talk a little bit about it later. It leads to JMJD3 expression. Rapamycin has been thought of as a longevity drug. Inhibition of the mTOR pathway. Again, the same factors, the activation of those genes, it has to do with heterochronic parabiosis. That's where you sew two mice together and across their bloodstreams, the young mouse gets older and the old mouse gets younger. And something called integrated stress response. So we want to say that what we're talking about, this factor, JDJM3, shows up all over the place in the natural processes of maintaining longevity, the natural restorative processes, and in the interventions we can do to create long lifespans. Let's go on to the next slide.
Summarize what Vince just said in a slightly more colloquial way, with jargon more. So in the longevity science movement, there are lists of approaches to triggering greater health and longevity. And we've looked at all the major ones, and not all the major ones are here, but we could list them. And what we find is the more we look at the most well-known longevity science mechanism interventions talked about today, we find that they all either trigger JMJD3 or they trigger the cholinergic anti-inflammatory pathway.
And in many, many cases, both, because one triggers.
Yeah, that's right. We can't find a third mechanism. We think there are likely only two.
Yeah, what we're saying here is if you want to falsify our approach, if you want to prove us wrong, we think being proven wrong is one of the best things that can happen to a scientist. So I'm ready for that if that's the case. If you want to falsify the approach, please show me an approach to extending lifespan or to creating a major health intervention that doesn't involve what we're talking about. We're making a big claim here. Let's go on to the next slide.
Yeah. Oh, wait, did I go too far?
Okay.
Oh, I didn't. There we go.
Heterochronic parabolosis, again, I said you sow the bloodstreams. You literally sow one mouse to the other, and you cross their bloodstreams, and one mouse gets older and grayer and dies younger than they would, and the old mice get younger and their hair gets fuller and they start having sex more and they literally get younger. This was an amazing discovery about 15 years ago. We didn't know how it works. We now have very good reason to believe, and there's research on this, research publications. Almost everything we claim is backed by one or numerous research publications, that it has to do with this inhibition of H3K27 methylation and the expression of JDJM3. Let's go on, next slide. Now, what are some of the things that inhibit the histone demethylase that create longevity, that create natural, that are interventions? Well, some of these are ancient, 4,000 years old. They were developed, and acupuncture is another example. They were developed because they worked, and people have used them for millennia and have not known why they work. We now believe we have explanations of why they work. Systematic breathing techniques, hyperoxic devices, Steve will talk about those. Natural sounds, which activate the vagal system, electromagnetic pulses, such as generated by pulse electromagnetic frequency devices. And this is the point in the discussion where I should put on my unit. It's one of those units, and you can buy these for
I have the same unit he has.
$225, $250 at Amazon.com, and actually do this for yourself. Steve and I have been having a ball doing these with many noted personal consequences. We'll try and talk about some of these in the presentation coming up to the London Futurists. Red and infrared light device and dietary substances. Again, inflammation tends to inhibit the operation of this JDJM3, the expression of it, and it tends to inhibit the cholinergic pathway that Steve has talked about so much. So inhibiting constitutional inflammation could be important too. This can happen through a number of herbs. And there are all kinds of multiple natural processes as well that has this effect, like getting plenty of rapid eye movement sleep, no matter how you get it. Let's go on to the next slide. Now, Viroxia, we believe, is an important technology that is variable variations in oxygen levels. In some very long people living in certain mountainous regions, well documented by the literature of supercentenarians, there are people who have to run a couple thousand feet up and down a mountain every day to get their water supply. This causes a variation in the amount of oxygen they get. And Viroxia changes the expression. Research shows that this has changes in the expression of JDJM3. umbilical cord blood plasma. Okay, plasma, many recent experiments has to do with factors in young blood. You've all heard but recently a great deal about there are factors in young blood, sometimes called elixir, that may have to do with major age reversal. Well, what happens when you have cut off an umbilical cord blood plasma? You cut off the blood supply to the cord blood. The cells in that cord are going to start screaming and go into a state of severe hypoxia, lack of oxygen. And we believe that oxygen with EWOC therapy, which is oxygen therapy, might be the key. Next slide. Is this you, Steve?
Yeah, I think it might be. It is.
Yeah. Okay.
Yeah.
Take it away, Steve.
So about oxygen therapy, I don't know how closely you follow the studies about health and longevity. Lately, there have been a slew of studies about how walking is healthy, right? Or walking at a fast pace, and so on, a number of steps per day. Why is that healthy? Well, if you're moving, what you're actually doing is getting oxygen through the capillary system, right? Through the arteries into the capillaries and then return to the heart through the veins. And back in, let me just show you. Well, I'm not going to show, I'm going to go quickly here. There is a lot of detail to all of this. So it turns out that a German technology person back in the last century, think of him as an Elon Musk sort of fellow. He invented a TV set in Nazi Germany, actually did a demo to Adolf Hitler. He was captured by the Russians, by the Soviets after the Second World War, and he helped the Soviets build their atomic bombs. He won 2 Stalin prizes. And then in 1960, he devoted himself to biology, and he came up with something called oxygen multi-step therapy, which is about doing exercise while inhaling highly concentrated oxygen. And in the West, in the last, I think it's just the last 10 years, a technique has evolved that's called EWOT, EWOT, exercise with oxygen therapy. And this slide, which will be in the PDF that Dr. Coehlo posts, that is in the PDF.
By the way, these slides are made in Steve's house. This is nice.
Yeah. This is my I have my exercise device in my apartment, and see this bag here? That's a 900-liter bag that I fill with oxygen with this oxygen concentrator. Here's my aerobic exercise machine, the Max Trainer. And what I do is I wear a mask. You can see a person with a mask here. Wear a mask while doing this aerobic exercise training. And I just do 15, 16 minutes, and I can empty that 900-liter bag in 16 minutes to 20 minutes. And the health effects are profound. And on this slide, there are a lot of resources you can look up. I highly recommend you watch this YouTube video by Robert Rowan. It's great. The fascinating things, I began using EWOT 2019, transformed my health in significantly positive ways. And the explanation for why it's so healthy was actually only discovered last year, 2020, the hypoxic paradox. This diagram is important to understanding what that is. I don't have time to review it today. And the last thing we want to say is it turns out that doing EWOT triggers viroxia, that is a drop in the oxygen level that each cell senses throughout the body, including capillaries that are reopened by EWA. Viroxia, it turns out, perturbs the electron transport chain, which triggers JMJD3, resulting in H3K27Me3 demethylation and rejuvenation processes. So among the most healthy things you could do is this new technique. Well, I think it's the most healthy longevity promoting technique. I'll tell you why. Because when you do it and you're getting oxygen in at high concentrations, every cell that is touched by a capillary is getting increased oxygen. How else can you ensure that every cell gets the oxygen it needs and the nutrients it needs? And when you do this therapy aerobically with high pressure, get your heart rate up, more capillaries turn out to open up, and it reduces the need for oxygen consumption. Anyway, that's viroxia and EWA. Anything more, Vince?
Yeah, let's move on, Steve. I
Okay.
think these two slides are important because we are making claims to have made discoveries that people have been trying to do for thousands of years unsuccessfully. So this is a disclaimer of what we are not claiming and what we are claiming. We're not claiming we understand all the epigenetic pathways of rejuvenation. They're devilishly complex. It's going to take probably the rest of this century. Right now, everybody is on board. You ask them about what is aging about, and they say, "Oh, it's about epigenetics." They wouldn't have said that 10 years ago, but how and why, it's going to take a long time to know. But it has to do with all of these things, and all of these things on the list below relate to JDJM3 expression. We know because we've looked at the literature across the board. Let's go on to the next slide. We're also not claiming that we understand all the processes of natural body rejuvenation. There's many of these. They're complex. It will be years before we're understood. You look at the history of this particular subject of JDJM3 and longevity and what we call younging. You know how old that is? It was started by Steve and I when putting together pieces of research back starting with Muramoto in the 1914. But the history of this thing is 3 months old, 4 months old. We're still discovering things all over the place. And we can be wrong about some things. If I'm wrong, I'm willing to be wrong. Again, we're convinced that most or probably all of the natural processes having to do with health creation and the natural forces of rejuvenation, like stem cells, and I think we might have time for a slide on that, are due to JDJM3 expression. And just say that we see it as we look at more and more things, as we try and disprove this body of work we're at now. We have not been successful at disproving it up to this point. Next slide. Yeah, just one of the natural body processes is stem cell renewal. Cells renew all the time. It is a natural process going on. Your blood cells have a lifespan maximum of about 4 months. Your red cells that you have in your body right now, all those blood cells, they didn't exist 6 months ago. And they are created by the reproduction and division of stem cells. However, with aging, stem cells get aged and grumpy and less capable of renewal. So we know that some of these interventions, which activate JMJD3, can be used to create health via normalizing and accelerating the functioning of stem cells and the health of your stem cell populations, so that your stem cell populations don't run out. We've read the whole blog on this subject, like on many other subjects this whole blog's on. Have a look at agingsciences.com if you want to read more detailed articles. Let's go on, Steve. We're getting close to the end here. Again, the JMJD3 shows up in the process of differentiation and in your developmental progress. You absolutely have to have it. But just go on from here. These are points. You can come back to these slides and view them. Again, neurogenesis, the creation of new neurons. Again, cycling back to the lifespan aspects of this. Very early in embryonic development, you have to have high degree of JDJM3, or you can't get differentiation. You won't grow limbs, you won't grow organs. It is a master switch that has to be thrown. At reproductive maturity, we've talked about this earlier, Steve talked about this, it's significantly reduced at this normal aging point, this inflection point at about 85. Now, what happens after that is that the normal balance slowly shifts between age 25 until maybe you're in your 80s, late 70s, 80s, maybe early 90s. And there's more and more HK327 methylation. And with advanced aging, this methylation prevails. We believe that there are a number of approaches we can pursue and do pursue right now for reversing this methylation, for extending our old age, and that it may be possible for there to be, the Harold Ketcher in his animal research suggests that it may be possible to have a whole body intervention which resets us to 25 or so and gives us a whole thing. We don't know what the best approach to doing that is, but we know a number of piecewise approaches now, and we're pursuing them. Next slide. Again, perturbing mitochondrial transfer chain is one way of doing this. Next slide. Here are some publications. You can refer to them later on, give some more details. Next slide. This subject is very hot. the hundreds of thousands of articles on JDJM3 and on demethylation. And they show all across the literature. You find them in cardiology, you find them in psychiatry, they have to do with mental states. The one exception is longevity science. Until Steve and I started talking about JDJM3 with regard to longevity 4 months ago, nobody else has. We can talk about our conjectures of why in the discussion period. Next slide. Again, these are our articles you could look at for more and more details on all these subjects. Next slide, please. Basic message. Couple poems. Do you want to do this one, Steve? And this is your...
About the cholinergic anti-inflammatory pathway. Basically, virtually unknown among longevity science leaders and among health professionals, the cholinergic anti-inflammatory pathway. What is it? For a million centuries, evolution has been establishing a mechanism in mammals, including in humans, discovered by the ancients, understood only recently. As we saw last lecture, this mechanism can profoundly impact physical health, survival probability when triggered at regular intervals, that is daily, by means we understand, and we've talked about. The inflammatory reflex is the physiological, neurological, biological mechanism explanation of the longevity promoting effects of inflammation limitation primarily at splenic macrophages. The inflammatory reflex is the smile of longevity.
Okay, that slide really inspired me. So I thought I would imitate that with a second slide that deals with the JDJM3 effect. That diagram on the left, by the way, shows the course of evolution from 1 billion years ago, when the sun began to affect the earth, right up to the very, very recent period. Our species is only about 100,000 years old. We are really new kids around the block. And so I wrote this poem, which I can only, since we emerged as the best ever apes out of East Africa, we have dreamed and fantasized about very long lives. To me, they are lives of wisdom, generosity, moving forward, always forward, moving the species forward, but always elusive. No fountain of youth has ever proved to be real. Plenty of imitation ones. I visited about 5 different fountains of youth in Latin America, Europe, the United States. And how could it be that now, finally, just right now, right this minute, right as you're experiencing it, after we've explored quarks, ancient galaxies from the earliest in the history, quantum physics, we're finally getting around to understanding how the longevity fantasy can be made real. And we believe the science of histone demethylation is the best candidate for that longevity. So we're pursuing it. Is that it, Steve, or is there another slide?
That is it.
That's it?
Oh, it is it. Yeah.
Yeah. Well, there's a number of...
So we saved the version of the presentation that talks about something I understand that Dr. Coehlo brought up a couple sessions ago, about this thing called the Copernican delay. And the slides are on my notebook here, but they didn't get up to Microsoft OneDrive.
Why don't we go to questions?
Yeah, any questions? Yes.
One of them was on a couple of the slides. It seemed like the definition of stress bounced back and forth. One of them, mitochondrial stress, and that
Yes.
definition versus the stress that has to do with, find it the stress response.
The kind of stress that has to do with the electron transport chain.
Back when you talked, you mentioned that Van Chen is like the expensive cholesterol pill and the stress response to that. And yes, it is the electron transport chain.
Transport chain. That's right.
But it
So,
seemed like there was two different kinds of stress going on.
right, let's go back to, let me go back to that initial diagram. Here we go. So,
The electron transfer chain is the basic way we get energy in cells, and it happens in mitochondria through a number of complexes, which allow us to convert the oxygen we breathe into energy via a energy molecule called ATP.
right. And the electron transport chain, I think your question.
It was actually the definition of the word stress, because stress can come in a couple different forms. Whether it's the mitochondrial is overstressed, overworked, fatigued, and it's not absorbing anymore, or stress as in an environmental influence is causing it to have it. I was looking at the
Stress
word
is a
definition.
complex phenomenon, and I'm uncertain that there is any complete definition of stress anywhere. So let me just clear up this electron transport chain problem. Excellent question, and we want to talk about. So the electron transport chain exists in the mitochondria. So for example, at this complex here, which is the electron transport chain, would exist in the mitochondria. So sometimes the literature talks about mitochondrial stress, and other times it talks about electron perturbing, that's the word that's used in the literature, perturbing the electron transport chain, and which is kind of the same thing as mitochondrial stress.
Yeah. With regard to the question, which I did not get fully, so this may not address all of your concern, there is a lot of literature about stress response. There is something called the Stress Response Society. I've spoken there, attended their meetings, and there is a phenomenon called hormesis, the essence of which is that you need small amounts of stress up to a certain level to maintain health. We are not designed to function only in the absence of stress. We're designed as mechanisms to expect stress, and low levels of stress are necessary to stimulate us and give us energy. It's a science called hormesis. You can research this on your own.
Just to supplement what Vincent said, the definition of what actually triggers stress is changing as time passes. So it can be psychological stress that triggers mitochondrial stress, or it could be the stress of aerobic exercise, or it could be the stress of these pulse electromagnetic field devices, or it could be the stress of infrared light hitting your body. That's why this term, when we think about stress, we think about, from in a personal level, we think about psychological stress. But when we're talking about mitochondrial stress or electron transport chain perturbation, the more that time passes, the more we're learning, oh my gosh, electromagnetic waves also trigger stress. And in fact, let me find the slide real quick. I want to show that. This is really a kind of a wild thing. Here's the slide I wanted to speak to. Take a look at this frequency-specific interventions. These are interventions that trigger mitochondrial stress. I have all these devices. I'm not wearing my Apollo Neuro today, but I have a couple of electromagnetic pulse devices, PEMF, and these aren't even my ones I think are my favorite. I also have some red and near infrared light devices, and these all trigger stress. What is going on there, right? This is just speculation. Something to think about is they only trigger stress at a certain, when the frequency of the sound or the electromagnetic pulse or the light or the electricity is pulsed. And the effect on cells is different depending on the frequency of the pulse. So one question to ask, is it really these devices, or is really the true independent variable the fact that our cells have an ability to discern a pulse? Is it the pulse itself, the frequency, that is the independent variable? We don't know. All we know is these devices can provide profound benefit.
I might comment that many natural phenomena, such as cell reversal to earlier states as part of renewal, require senescent cells, the stress of senescent cells. So that biology uses stresses in numerous ways to trigger numerous processes. And if you removed all stress from us, we'd all be dead. It would be a stress-free environment.
I don't know if that answers your question.
It did in some ways. It definitely took it bigger, but I know the mitochondrial is such a little powerhouse. Is it releasing? It says it's declining and reversed the JMJD3, but in terms of the stress, is it taking it, switching it, producing something positive with it? Is it releasing something?
JMJD3 expression can increase ATP, which is the energy that powers the cell. JMJD3, as Vince was talking, also unlocks the cell for regenerative reprogramming of the cell's internal epigenome.
Okay. That does have decline effect.
That's right.
Versus a decline. Instead of taking something away, it's actually adding and contributing to something.
There are a lot of, if you go to Amazon and look for red and near infrared devices, you want to buy one. There are a lot of devices you can buy, and if you read the reviews, pretty much they're positive reviews. I've shown red light on my face. I can feel the collagen on my face after I do that, and it relieves pain. Vince has some amazing personal stories. There's another question here.
Oh, I just didn't see what I was just saying that you didn't really. She followed it up. She followed up her question with a little bit of what I was going to say.
Okay.
Because it didn't seem like you really answered whether you were using two definitions of stress.
Right. Any other questions? Yeah.
No one else has it.
Yeah.
Well, you mentioned on the exercise with the oxygen therapy. Did you have a chronic condition prior to doing the exercise?
I did. I have.
Did
I have
it relapse?
I have
over?
cardiovascular disease,
Mhm.
and I was having trouble with exercise endurance, and that particular technique, EWAT, that is an enhancement of the technique described by that German scientist 800 years ago. His book in English was published 30 years ago, is the most rejuvenating cardiac related therapy I've ever done, including any drug prescribed by, cardiologists or general practitioners. And if you look at EWAT, if you go to YouTube and you look at EWAT and you look at that specific page, go to Robert Rowan's video, it's 8 minutes. It's remarkable the effects that EWAT can have, and you can watch a lot of videos of people talking about the benefits. And the wild thing is, so EWAT's been done for a decade now, but the radical benefits it can have were at a molecular level were really only understood in that article that's in the slides, the hyperoxic hypoxic paradox. It's an amazing and emerging technique for rejuvenation.
Breath work that they try to do the training where they take and they just do a concentrated deep breathing. For the 20 minutes.
I am not certain about that.
There may be
One thing
different-
that's clear is that, so EWAT is aerobic exercise with high concentrated oxygen, and then you go to normal oxygen level. That is clearly triggering the cellular mechanism we've been talking about. That is histone demethylases, JMJD3. Ancient breathing techniques actually trigger the vagal system. So that is a kind of brain displaying mechanism. Breath meditation triggers the vagal system, which is increasing acetylcholine in the brain and in the spleen. It might also trigger the cellular level mechanism. I don't know about that, but I do know it triggers this secondary, is the pathway we talked about last time.
We are very busy now trying to understand the link-ups and relationships between the two Jungian techniques we've talked about, the cholinergic anti-inflammatory pathway and the JDJM3. And we see connections, and this will be something that we'll be revealing. I expect that what you are seeing here is just the beginning of the story. It's going to be a long time before the story can be simply told, and we'll have the most important ramifications laid out.
Right. With regard to this idea of the Copernican delay, which is, it's given that name Copernican delay because Nicholas Copernicus discovered, he figured out with math that the Earth orbited the sun, right? But it wasn't accepted by the establishment for 70 to 90 years. Galileo was tried for heresy by the Catholic Church because he wrote about it. And so the idea of the Copernican delay is that there can be an actual discovery in the public domain that isn't leveraged by the establishment for decades, right? Vince and I, we don't own any rodents. We just read abstracts. That's all we do. and we,
Articles too.
yeah, and the articles, and we try to figure it out. The amazing thing is the cholinergic anti-inflammatory pathway, this brain to spleen mechanism has been close to settled science for a decade. And how many people have heard about it? It takes time for new knowledge to penetrate establishment practice.
It's matching a lot of the knowledge that I already have, but it's almost like this, like the missing piece that kind of adds into there. I know
Right,
about breath work, and I know about the herbs, I know about
Right.
mitochondria, and I know about those little molecules and absorption. But I haven't heard about this particular, and that's why I just kind of squeeze it a little bit so that I can check it out.
right,
It's kinda
right.
Like it's exciting, and as I talked about with my own daughter having diabetes, you know, I had asked about the influence.
I looked
of-
that up, and
the
in the current, the version of the PDF that will be uploaded, I have a page on the cholinergic anti-inflammatory pathway of disorders. What disorders it has been shown to address, and there are a lot of them, including diabetes.
Because
Type 2,
It's not type 2, versus type 1, she has as an adolescent. And so,
Yeah.
any benefits though, if possible, especially with the, what did you call it, the galantamine?
galantamine. Galantamine has been shown to improve outcomes in Alzheimer's patients and also increase survival probability. And there was that study that I referenced last week. I found another study that replicated those same results with a larger study population, published in 2017. I found the study just yesterday. I have to say, for my personally, I'm trying to trigger this vagal mechanism, brain to spleen, right? And galantamine triggers it, but we think it's relatively clear that REM sleep triggers it. And this device here triggers REM sleep. I've documented that with my Oura Ring and my Fitbit. And I would love not to have to pay Amazon, for the bottles of galantamine because it's expensive. And I'm now doing testing to see if I can consistently get better sleep and especially better REM sleep with this device called the Happy, HAPBEE, with the power nap with the power nap frequencies, which is 4 hertz. It appears that that active triggering the cholinergic anti-inflammatory pathway appears to be triggerable between 3 to 5 hertz of sound or electromagnetic waves or light. This is speculation on my part, but it appears to me that it works. So I'm hoping to give up having to buy galantamine. I just use this. It's a little weird to sleep with, but yeah. Any other-
I just love it. I love what you've got going here, and I just,
Yeah,
press on it. But thank you.
you're welcome. Thank you. Any other questions? Thank you. Dr. Coehlo.
We welcome, by the way, you writing us if you have any further questions or comments. Yeah. Okay.
Thank you very much. So Thursday will be our last class. And yeah, pull it all together. So any last questions or comments? Very good. Okay, see you all Thursday.
What? Bye-bye, Vince. We'll talk tomorrow.
Has he had any chronic illnesses that have gone away with his oxygen
Uh,
saturation?
He has had remarkable experiences. His wife has had scleroderma, which is a skin disease, and she was using near infrared light. The scleroderma is going away after years of being untreatable by traditional means. Yeah. it's amazing.
That sounds good. I'm curious for that breath work though.
Yes, yeah, breath work is
Because that's where I don't think I'm gonna be able to get a hold of any natural oxygen or oxygen,
right.
but closest means I could come to would be the breath and
Right,
doing exercises or
Right,
meditations with it. myself.
right.
And hence why I would like to visit as close to it as possible. I can
It's on my list of things to do to become more familiar with breath.
get oxygen saturation. I did that here in town once. I had the one guy who comes from California. I did a breath work